Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy. So, we were discussing about falling stage systems tract as part of our series of discussions on the different types of systems tract. And in the last class, we have discussed about some aspect of the falling stage systems tract, particularly with respect to the erosional aspect, which is associated with the forced regressive phase. And we have tried to understand how incised valley systems they form and what are the overall implications of such incised valley systems. To continue that discussion, in this class we will be looking into the other aspects of the falling stage systems tract. So, apart from the fluvial incision within a FSST, we can also observe depositions going on as offlapping shore-face lobes on the continental shelf, as offlapping delta lobes in the inner to outer shelf as different types of macroforms, in the shelf edge area forming delta through downlap on the continental slopes, as well as on the slope and basin floor area in the form of successive submarine fans. So, these are the different types of deposits or the distribution of the depositional systems that can commonly observed during the FSST within the marine depositional system. So, what are the common diagnostic features for FSST? So, it is commonly confined within the shallow marine deposits. We cannot get the FSST deposits dominantly in the marginal marine or in the fluvial part, because that part is subjected to erosion. So, it is mostly confined in the shallow marine deposits with prograding and offlapping stacking patterns. This is very important, prograding and offlapping stacking patterns. These shallow marine deposits can have edge equivalent to deep water submarine fans. So, we can try to understand what are the different depositional processes that commonly goes on during this falling stage systems tract or during this phase of forced regression. So, we can divide this entire phase of falling stage systems tract into two divisions. One, the early falling stage systems tract, and then the late falling stage systems tract. So, how we can define this early falling stage and late falling stage? If this is the base level curve, then the falling stage is starting from here at this point. So, from this point maybe up to this is the early stage, and then the rest of the part up to this point is the late phase. So, we are first trying to understand what happens during this phase, that is the early forced regressive phase, early FSST, and then we will try to understand what happens in terms of depositional process and products during the late phase of the FSST. So, again we will look into the high stand prism in the continental part. So, it looks like something like this. If I want to make a 3D diagram, it will be something like this. So, this was the water level at the end of the HST. Now, from this level, base level is falling down to, say for example, level 2 somewhere here, which may be something like this. Say this is the shelf area, and from here on we have the shelf break. So, maybe it is coming down to somewhere here, which is level 2. So, now the sea level is somewhere here. So, in order, say for example, if you have a river system coming down to this level, coming over here, earlier it was supplying the sediments at this point, and we were getting a delta system forming at this part, as well as the strand plains or the shore deposits were forming over here in this zone. Now, as the sea level is falling down or the base level is falling down from this level 1 to 2, and as in the previous class I told you that this is not like drastically or sudden jump from 1 to 2. It is a very gradual fall from 1 to 2, and there can be multiple such planes, time planes we can think of, we can imagine, and those time planes will have different sea levels or base level conditions like this. Say for example, if I take this particular base level condition, maybe somewhere at 1A, level 1A. So, when the base level was here, definitely the river valley will incise up to this. The river valley will definitely incise up to this level, and the sediments will now be deposited over here, because this is the base level now, this is the sea level now. So, the delta will form over here, and since waves are available at this level now, the longshore current is playing over here. So, the sediments will be distributed along this zone and we will get the shore deposits forming over here. So, what is happening in this part? This part is the river valley is going down over here due to its down cutting. So, in this part the floodplain area will now face starvation in terms of supply of sediments, because there the flooding event is stopped now. We can get some local tributaries which may be supplying sediments over here, and the river valley will try to incise, will down cut. And what we get over here, these are the remnants of the earlier shore deposits. So, basically if I look into the section, this was the early deposit. So, from there we are now getting a new surfaces formed, where we are getting the accumulation of the new delta or the new shore face deposit. So, basically we are getting this kind of offlapping lobes. So, for each such phase of fall in the base level, we will expect formation of this kind of offlapping lobes. And this area which is remaining over here, for example this part, for example this area, they are the remnants, and over this area we can get or we can expect some soil forming process, some petrogenic processes are going on, or simple bypass is going on over there. Now, in this way, when say for example it is coming down to this level, say this is level 1B. So, for this particular level, the river will further cut down up to this, and the delta will now form over here, and in response to this delta, the wave activities and the longshore currents, the sediments will be distributed along this zone. So, the earlier delta which was formed during phase 1A, the remnant of these shore deposits, they will now appear as the remnant part of this offlapping unit, and we will get a new offlapping unit formed by this formation of this new delta. And in this way successive offlapping units will form, and the previous one will be preserved as a remnant, as it will be affected by this down current channel system, down current river system. Maybe some tributaries will form over here in these portions, they will also successively erode, rework the sediments, and finally what we get, some remnants remaining over there, which are the remnants of the earlier delta or shore deposits. So, remnant of these offlapping units will be characteristic in the shallow marine part. Finally, when it is reaching over here level 2, so definitely the river valley is now incising over here, and it will supply the sediments in this area now. So, water level is here, that means this area is having very high wave energy, very high wave condition, and those waves associated with longshore current and rip current will remove these sediments along the shore area. So, we will get very well developed shore over here, as well as we will get a new erosional surface formed along this area, cut by these wave activities, which will be identified as or are commonly named as the regressive surface of marine erosions. So, this new erosional surface will form in the shelf area. At the same time, what we are getting over here, there is a high energy zone now, because there we are getting continuous wave activities, maybe some storm activities. So, all these high energy activities will make this entire zone highly unstable. Unstable in terms of regular processes, vigorous processes, in terms of wave activities, tidal activities, current systems. And this high energy conditions, this instability along this self edge because of this fall will result in formation of several canyons or several sediment gravity flows which will come down this slope and will get deposited over here as debris flow deposits. Now, what is the material available over here in this area? Basically, fine-grained pelagic and hemipelagic mud which were deposited during the high stand time as condensed sections. So, when this reworking is going on and these debris flows are formed, they are coming down this slope forming canyons. So, what is the major composition? Dominantly these are mud flow. So, we get dominant mud flow deposits and successive mud flow, say for example, the first one is deposited like this, the second one may be deposited over this. So, gradually they will try to backfill the canyon. So, they will gradually stack up, vertically they will stack up and we will get stacked mud flow deposits formed over here. So, maybe one mud flow deposit over here, another one over here, like some slump deposits. So, multiple such slumping, multiple such debris flow deposits which are dominantly constituted of mud flow, they will characterize the deep basinal part where we get this kind of very high density debris flow deposits or mud flow deposits as characteristic. So, definitely in these cases we can get at the bottom part the BSFR preserved, the basal surface of forced regression preserved, because these mud flow deposits will get deposited on the last HST surface. In this area also locally in some places we can get the preservation of the BSFR surface if that escapes the erosional process going on during these successive phases of fall of the base level. So, during this early phase of forced regression, early phase of FSST, several processes are going on across the basin. If I want to summarize them, if I want to jot down them one after another. So, most of the sand they will accumulate during this stage within the detached and offlapping shoreline to upper shoreface systems, because these areas, these portions, they are the sand depositing portions. So, those sands will be captured, will be occupied within the shore environments and then they will be reworked further and they will be distributed towards the downstream direction as the base level position is there, as the shoreline position is there, and they will form a new shore. So, all sands, dominantly the sand deposits will be confined over there. So, most of the sand that accumulates during this stage is captured within detached and offlapping shoreline to upper shoreface systems. A significant amount of finer grain sediments, they starts to accumulate in the deep water environment as mud flow deposits, because they are formed through reworking processes, and during the reworking the material available for reworking was the mud which was deposited during the previous HST phase. So, we commonly get two major sequence stratigraphic surfaces that commonly form during the base level fall. Number one is the subaerial unconformity, as we have already discussed in our previous lecture as well as during our class on surface. So, subaerial unconformity which will gradually form in the fluvial part towards the continental part and will expand basinward as well as towards the landward direction, and that expansion is associated with the shoreline regression. So, that is one surface. I will not go into the further detail about this particular surface as we have already discussed a lot about this particular surface. And the second surface, which is again another very important surface, is the regressive surface of marine erosion, which forms by the wave cutting, wave erosions in the lower shore face area. as the lower surface and also the part of the shelf is now becoming part of a very low water level depth, and that is now part of the wave reworking as it is above the wave base. So, depending on the energy condition, we can identify successive RSME surfaces during this particular phase. The basal surface of forced regression, the BSFR, it can be identified at the base of the all forced regressive strata ideally, but since there is successive erosions are going on, since this RSME process is going on, in many places we cannot get preservation of this BSFR. So, we can identify these commonly at the early fall mud flow deposits at the deep basinal part. We can also identify this surface in those areas where it has escaped this reworking by the RSME processes. Otherwise, in most of the areas, RSME surface will rework and overprint the BSFR surface. This aspect we have also discussed in detail during our class on surfaces, particularly on this class of BSFR and RSME. So, I will advise you to go back to those classes and go through that part. Now, coming to the second phase. So, we are now looking into this part of the curve from here to the end, that is the late phase. The late phase of the forced regression or late FSST. So, what are the depositional processes and what are the products that we can expect during the late FSST phase. So, we can think of the same kind of scenario again. So, over here what we are getting is the earlier HST prism was there, and then we have the shallow marine to shelf area, and that shelf area is reaching to the shelf edge. From here we have the slope and then the deep basinal part. Now, at the end of the early FSST, what we have seen at that particular phase, the condition was something like this. So, the sea level was somewhere here, the base level was somewhere here, and in response to that there were remnants of the early shore deposits which are formed like this, through which the river valley was incising, and it was coming down to this level, forming a delta or the shore deposits over here. There were some tributaries were forming. This area was facing some complete bypass sediment starvation, and this river valley was going through incision. So, pedogenic processes are going on over here. Now, the base level is coming down to this, that is at the shelf edge. So, this was level 1 and we are coming down to level 2, where we are reaching to the shelf edge. Base level is going down to the shelf edge. So, what will happen at this phase? So, during this phase, definitely the river valley will try to come up to this level. Just like the previous case, definitely from 1 to 2, again we can find out several levels of fall in terms of different time planes. So, we can think of again formation of multiple such shore environments and the delta which were formed during the successive phases of fall, and we can get their remnants as the river valley is gradually coming down, or river valley is gradually down cutting, incising. So, when the river valley is reaching up to this area is facing further incision, as we have discussed in our previous class. When the base level comes down to the shelf edge level, there is the second topographic break, and in response to that overall river valley will face further incision. So, this area is now facing extreme amount of erosions, and there will be several tributaries forming over here, and the remnants over here will be very less. The remnants which were preserved, which are present during the early FSST, they will be reworked further, they will face further erosions, or they will face very strong pedogenic activities. In this area, we can get remnants of the shore deposits, shore phase deposits, which will be the remnants of this second phase or late phase of the FSST during successive phases of fall. And then finally, we get the deposition of sediments over here in the form of delta. Now, this delta will form in the form of offlapping lobes. Why offlapping lobes? If the base level falls further, say for example, it is coming down to level 3. So, for this level, we will get this kind of offlapping lobes forming the delta. So, it is like if this is the slope, so the base level was here and it is coming down to this. So, for that part, initially the delta lobe was like this. Now, for the next phase of fall, the delta lobe was like this and this part is eroded. For the next phase, the delta lobe is like this and this part is eroded, and in this way we get successive offlapping lobes forming over here. Where it is forming? Along the slope. They are forming at the self edge and downlapping on the slope. So, this delta which is forming over here now is the self edge delta. So, the self edge delta will form during this late phase of the FSST. Now, when the water level is reaching over here level 2 or level 3, suddenly the water depth is very high, significantly high now with respect to this sudden increase in the slope. And the wave reworking which is going on over here, or if I think of the wave equilibrium profile in terms of the wave energy, that will be definitely much shallower like this. So, it will not be able to cross cut the substrate anymore or the sediments which are accumulating over anymore, because the sediments which are coming over here, which are accumulating over here, their clinoforms, they are much more steeper than the wave equilibrium profile. So, the wave reworking will stop over here. So, as a result, we will not get any RSME surface at this particular point. We will not get any RSME surface to form in this area. So, there is no erosion going on, and since there is no erosion, we will get a very well formed delta, the self edge delta formed at this particular phase. So, now what is happening along with this? This area is under high energy condition still, because all the sands are now supplied over here, and this area, the self edge, is now very unstable in terms of energy condition, in terms of huge amount of sediment supply, and they are just at the verge of, just at the edge of relatively higher slope. So, definitely the water will try to rework the sediments from this area, the river will supply the sediments from this area, and they will come down the slope in the form of some canyons, some channels, and those channels will supply sand over here in the form of some fan. So, what will be the characteristic of this flow? They are high density turbidites, high density turbidity currents, where the dominant unit is the sand supplied in this area, sand supplied by the river earlier, which were getting deposited in the shore areas in the delta part, delta mouth bar area. They are now supplied over here and they will come down, those sands will come down the slope through channels where high density turbidity currents will flow and bring those sands over here to form sand lobes. So, multiple such current system, multiple such channel system will form along this slope area, and they will come over here and form successive high density turbidite deposits. So, during this late phase of the FSST, we are again getting a very instability in the self edge area. However, we are getting a self edge delta is forming over here, and along with that self edge delta, what we expect is formation of submarine fan system due to accumulation of successive high density turbidites in the deep marine part of the basin. Whereas, the entire self area and the shallow marine part, including the marginal marine or fluvial part, that will go through extensive erosion caused by fluvial incision and bypass. So, this is the overall distribution of the depositional processes and the products that commonly goes on during the late FSST phase in ideal condition. Definitely it can vary from basin to basin depending on the extent of this base level variation, base level change and the nature of the basin, nature of sediment supply. So, if I want to jot down what happens during the late FSST, the sediment mass balance, it changes in the favor of deep marine fans, where mostly we are getting the sand deposited now. Earlier, during the early FSST, it was dominantly mud depositing condition through submarine mud flows, submarine debris flows. But now we are getting high density turbidites, which is supplying a very dominant phase of sand into the deep basinal part, and we are getting dominant sand deposits in the form of submarine fan. Towards the continental side, the subaerial unconformity, it is continuing, it is forming and expanding basinward until the end of the base level fall. And if the base level fall reaches up to the self edge, the subaerial unconformity will extend up to the self edge. Once the shoreline falls below the self edge, the formation of this RSME surface, regressive surface of marine erosion, it stops forming because the seafloor gradient of the continental slope is much steeper than what is required by the surface profile to be in equilibrium with the wave energy. As the RSME surface is unlikely to form beyond the self edge, particularly when it is into the continental slope, which is relatively steeper, these falling stage deposits are bounded at the top by the subaerial unconformity or its correlative conformity surface and at the base by the BSFR surface. So, along this slope area where this RSME reworking is absent, we expect the BSFR surface to be preserved as the contact between the earlier HST deposit and these offlapping delta lobes, which are forming during the late phase of the base level fall. The fluvial systems, they will continue to incise into the high stand prism and they will bypass the rest of the subaerially exposed shelf until and unless the base level comes below the shelf edge. As we have discussed in the previous class also, when it comes down below the shelf edge, then there is another topographic break and the entire river equilibrium profile will try to adjust itself and we can expect a further river incision, which will affect the entire shelf as well, which is now entirely exposed. So, unless the base level falls below the elevation of the shelf edge, the river incision will be confined into the marginal part or shallow marine part only. The turbidity currents of the deep basin, they are dominantly of high density type because there is a huge amount of sediment supply at the shelf edge as the river is bringing huge amount of sand through this incision process, and hence they tend to be overloaded and aggradational in nature. That means the sediment load is much higher with respect to the energy of the flow, with respect to the reworking capacity of the flow. So, sediments will try to get dumped, will get accumulated along their entire course. So, overall the density of the turbidity currents will be very high in terms of sediment load and they will try to accumulate as soon as they will come down to the slope break or the end of the slope, they will reach the deep basinal floor. So, during this entire phase of falling stage systems tract, we can understand, we can observe there are several changes occurring. So, starting from the early phase of the falling stage to the late phase of the falling stage, we can expect different conditions occurring in the continental side, in the fluvial part, to marginal marine part, to shallow marine and shelf part, to the deep basinal part. In the fluvial part, we are expecting dominantly subaerial erosions, subaerial unconformities, which is associated with river incision, bypass, pedogenic activities. Now, that incision will gradually expand towards the shallow marine part, into the shelf part as and when the base level will fall further, and depending on this extent of base level fall, the extent of this expansion of the subaerial unconformity will be controlled. So, accordingly, if the base level falls even below the self edge, the subaerial unconformity can expand up to the self edge. During the early phase of the FSST, depending on the level of the base level fall or the extent of the base level fall, we can get some intermittent delta forming, some surface deposits forming, which are associated with formation of successive RSME surfaces and successive offlapping lobes, which are getting preserved as the remnants. Whereas during the late phase of the falling stage systems tract, when the base level is falling further below, maybe reaching up to the self edge, there this entire self area is getting exposed and we are getting a delta forming at the self edge along the slope as downlapping lobes, where the RSME surface will be completely absent, the wave reworking will be absent, which will help in accumulation of that delta, as well as the supply of huge amount of sediment, huge amount of sand by the river systems, which are incising from the continental side through the Salomarine and through the self area up to the self edge, bringing huge amount of sediment. So, they will produce successive high density turbidites, which are sand dominated. During the early phase, we can observe that there are successive wave reworking leading to some instability in the self edge area, which may lead to formation of successive debris flows, mud flow deposits, which getting deposited as backfill canyon deposits and forming submarine fan in the deep basinal part. So, they are dominantly mud depositing condition. So, overall this FSST is very distinct in terms of depositional processes and its products. When we compare this with respect to the other systems tract, for example, already we have discussed about HST. In the successive classes, we will discuss about the other systems tract, and then we will also see that this FSST is very distinct in terms of the depositional processes and its products. And even within the FSST, the late phase FSST and the early phase FSST, they are quite distinct with respect to each other in terms of the distribution of these depositional systems, which is a result of the depositional environments, processes and the final products. So, we will further continue this discussion on this falling stage systems tract in our next class, where we will try to understand some other aspects of the falling stage systems tract. These are some of the references which you can go through for further reading. So, thank you everybody.